Hello everybody, this is Vipul Purohit and I welcome you back to my YouTube channel. My dear friends, in the series of videos which we discuss about with respect to the solutions applied to chemical thermodynamics, in this particular session we are going to talk about deviation from Raoult's law. Now what is Raoult's law is already being posted in my previous video, and if you missed it, no worries. I'm going to put the link of that particular video in the description box of this particular video. So let's start with deviation from Raoult's law. My dear friends, when we talk about ideal and non-ideal solutions, ideal solutions are those which obey Raoult's law. Non-ideal solutions are those which do not obey Raoult's law. Okay, I had already posted a video on ideal and non-ideal solutions previously. Once again, as I said, if you have missed out, I'm going to put the link in the description box. So now when you talk about deviation, means it's something which is going away from a particular statement. And that means, in other words, the one which is not going to obey. And hence, we say that non-ideal solutions are the ones which are responsible for the deviation from Raoult's law. So if you're going to consider a very simple solution, and that is a binary solution composed of two components, A as well as B, then the total vapor pressure of the solution is the summation of the vapor pressure of A as well as B. And therefore, we say that the total vapor pressure, that is P, is equal to PA plus PB, where PA and PB are the partial pressures of A and B respectively. Now when you talk about deviations, now there are two possibilities. Okay, one we call it as a positive deviation and the other is going to be negative deviation. So let's begin with the essential points of the positive deviation. And my dear friends, I am very sure that if you understand the positive deviation very well, then negative deviations are going to be very easy. This is the beauty of chemistry, is you understand one concept and apply it to the next concept. So let's begin with the very first point under positive deviation. When the total vapor pressure of the solution, which is experimentally determined, I'm talking about this total vapor pressure, alright, that means it is the summation of the partial pressure of all the components present. So when the total vapor pressure of the solution, which is experimentally determined, is greater than the one which is obtained by the Raoult's law, then it is termed as positive deviation. दोस्तों, जब हम साइंस की बात करते हैं तो हम एक्सपेरिमेंटल एज वेल एज थियोरेटिकल ऐसे दो कंसेप्ट्स की पढ़ाई करते हैं. तो जब एक्सपेरिमेंटल डेटा और जो थियोरेटिकल डेटा है वो मैच नहीं होता है तो हम उसे डिविएशन ये नाम देते हैं. अब यहाँ पे जो डिविएशन है वो पॉजिटिव है. पॉजिटिव मतलब ज़्यादा, ग्रेटर. और इस तरीके से हम क्या बोलेंगे, पहला पॉइंट इज कि the total vapor pressure of the solution experimentally determined. क्योंकि जनरली हम एक्सपेरिमेंट पे ज़्यादा यकीन करते हैं. थियोरी कैन गो रॉन्ग बट एक्सपेरिमेंट जनरली डजंट गो रॉन्ग. So and therefore we say experiment determined is greater than that obtained by the Raoult's law, and that is going to be called as positive deviation. Now my dear friends, there are going to be interactions taking place between the same substance as well as between different substances. यानी हम इंट्रा और इंटर ऐसे बात करते हैं. सो अगर हम इंट्रा की बात करते हैं, सो इंटरैक्शन बिटवीन ए एंड ए, बी एंड बी. अगर मैं इंटर की बात करता हूँ, सो मैं बात करता हूँ बिटवीन ए एंड बी. तो यहाँ पर ये देखा गया है कि द इंटरैक्शन बिटवीन द इंट्रा, दैट इज ए ए or BB, is going to be greater than the interaction between A and B. That means this, when I talk about A and B, this is going to be what? Inter. This is going to be what? Intra. So intra is going to be greater than that of inter. Okay, this is point number 2. We proceed to the next point. The process is associated with absorption of heat and hence the volume also increases. Now generally whenever a process takes place, heat is involved. Either it will be absorption of heat or release of heat. And accordingly, we call it as endothermic as well as exothermic. So when we talk about absorption of heat, it is going to be called as endothermic. Now, generally what happens, of course there are exceptional cases, but then generally what happens that absorption of heat is associated with expansion. और दोस्तों जब एक्सपांशन होता है तो जाहिर सी बात है वॉल्यूम बढ़ता है. ओके और दूसरी बात है मैंने बताया था आपको कि हीट इज एक्सप्रेस्ड इन टर्म्स ऑफ एंथैल्पी चेंज. दैट एंथैल्पी चेंज इज गिवन एज डेल्टा एच. और अगर एब्जॉर्प्शन होता है तो ऑब्वियसली द वैल्यू बढ़ेगा. ओके कोई भी चीज अगर आप लेते हो तो वो चीज बढ़ जाता है. सो एब्जॉर्प्शन ऑफ हीट से द हीट कंटेंट इंक्रीजेस और इंक्रीजेस मतलब पॉजिटिव. मैंने जैसे बोला है कि आपको कि वॉल्यूम भी बढ़ेगा क्योंकि एक्सपांशन होता है तो वहां पर भी पॉजिटिव आएगा. तो आप देख सकते हो जो नेक्स्ट पॉइंट आपने आपके स्क्रीन के सामने है डेल्टा एच इज पॉजिटिव and delta V is also positive क्योंकि absorption of heat हुआ है. So that means there is an increase in the amount of heat, so it is positive. Expansion of gas होता है, expansion of a substance होता है तो वॉल्यूम बढ़ता है तो इसलिए वो भी पॉजिटिव हो गया. अब अगर हम वेपर प्रेशर कर्व को ध्यान से देखें, दिस इज द वेपर प्रेशर कर्व माय डियर फ्रेंड्स. ओके ऑफ मोल फ्रैक्शन अगेंस्ट द वेपर प्रेशर. तो यहाँ पर अगर आप लाइंस देखोगे ओके तो आपको दो तरीके का दिखाई देगा. एक ये देखिए ये डॉटेड लाइंस है, आप देख सकते हो ये जो मेरा पॉइंटर घूम रहा है रेड वाला पॉइंटर ये आप देख सकते हो. दिस इज गोइंग टू बी द डॉटेड लाइंस. और वो डॉटेड लाइन क्या है वो वैल्यूज है दोस्तों. हमें जो मिला है वो वैल्यूज अकॉर्डिंग टू राउल्ट्स लॉ. Because we are talking about quantitative aspect, isn't it? We are talking about vapor pressure and it has got values. So we are talking about with respect to numbers. Okay, so this is quantitative. So as a result of which, my dear friends, this dotted line represents the values which are going to be obtained when we consider the Raoult's law. But then at the same time, here we are discussing about deviations. So obviously that experimental values will not be exactly in agreement with that of the Raoult's law. यानी जो एक्सपेरिमेंटल मुझे जो वैल्यूज मिलेगा वो लाइन इस डॉटेड लाइन के साथ मैच नहीं होगा. तो वो जो लाइन है वो एक्चुअली लाइन नहीं मिलता है, मुझे कर्व मिलता है. तो जहां पर भी आपको ये सॉलिड कर्व दिख रहा है, वंस अगेन आई शो इट बाय मींस ऑफ पॉइंटर्स. ये रेड वाला जो पॉइंटर है ये वाला दिस वन. ओके एट द सेम टाइम यू कैन सी दिस वन. ओके एट द सेम टाइम यू कैन सी दिस वन. अगर आप उसके करस्पॉन्डिंग एक्सपेरिमेंटल वैल्यूज के जो कर्व मैंने जो अभी आपको पॉइंटर से बताया है, अगर उसको आप कंपेयर करोगे विद द करस्पॉन्डिंग द थ्योरेटिकल वैल्यू राउल्ट्स लॉ का बाय मींस ऑफ अ डॉटेड लाइन, तो आप सब तीनों जगह देख सकते हो इट इज अबव. अबव मीन्स व्हाट ज्यादा है, और ज्यादा है मतलब क्या है इंक्रीज है. ओके और इंक्रीज का मतलब होता है पॉजिटिव. सो इन पॉजिटिव डेविएशन यू कैन सी दिस, जैसे मैंने फर्स्ट पॉइंट आपको बताया था कि the experimental value is going to be greater than that obtained by the Raoult's law. तो इस तरीके से आप देख सकते हो ये जो सॉलिड कर्व है वो डॉटेड लाइन के ऊपर है, मतलब उनका वैल्यूज ज्यादा है. So the solid line is the one which is the experimental values obtained, ये वाला जो आपने मैंने बताया है, और डॉटेड line is according to the Raoult's law. Of course, please ignore the spelling please, it is Raoults. Okay, please remember that. But any which ways, I hope you have understood this particular vapor pressure curve very well. All right, we now move on to the next point, and that is what are the factors which affects the magnitude of the positive deviation. Okay, कौन से ऐसे factors है. पॉजिटिव डिविएशन है ऑल राइट, लेकिन पॉजिटिव डिविएशन में कहीं पर ज़्यादा पॉजिटिव डिविएशन होगा, कहीं पर कम होगा. तो उसके लिए कौन से फैक्टर्स रिस्पॉन्सिबल है. फर्स्ट वन इज वी टॉक अबाउट डिस्प्लेसमेंट ऑफ चार्जेस पॉजिटिव एंड नेगेटिव अमॉन्ग्स द टू स्पीशीज व्हिच वी कॉल इट एज पोलैरिटी. दूसरा जैसे मैंने आपको बताया था अबाउट द इंटरमॉलिक्यूलर एंड द इंट्रामॉलिक्यूलर फोर्सेस ऑफ अट्रैक्शन between two different species and between the same species. Next one is to what extent association takes place amongst the component of the solution. All right, so association is all about bond formation, it's all about interaction, so it can be either less or it can be more. Okay, so depending upon the extent of association, the magnitude of positive deviation is considered. And of course, if we are going to consider the hydrocarbon, then we consider the chain length. Whether the chain length, of course, generally when we talk about chain length with respect to hydrocarbons, so we are obviously going to talk about the carbon-carbon chain length. Okay, so either the carbon-carbon chain length is shorter or it is going to be larger. So that also is going to decide the magnitude of positive deviation. Okay, so my dear friends, they are going to be those 4 important points. And the last point is examples. So some of the examples are, first one is the mixture of acetone and carbon disulfide. Second one is carbon tetrachloride and toluene. And the third one is carbon tetrachloride and heptane. There are many more also, but then we restrict to only few of these examples. So my dear friends, these are the 7 points that we have discussed with respect to positive deviation. And as I said in the beginning of this particular session, that if we have understood all these points, then I am very confident that the negative deviation will be absolutely very clear to you. So here we proceed towards the negative deviation. So now, in the negative deviation, obviously, as the name suggests, is going to be opposite to that of positive deviation. So when the total vapor pressure of the solution, which is experimentally determined, is less. Can you just check it out over here? It's less. There it was greater because it was positive. So यहाँ पर वो क्या है? Less. Then that obtained by the Raoult's law, and then it is termed as negative deviation. Okay. So greater का less करना है. In this deviation, the interaction between, that is, मैंने आपको intra और inter का interaction के बारे में बताया था. So over there we said the intra is going to be greater than that of inter. So यहाँ पर उसका opposite हो जाएगा. So the intra, that is intra में कौन कौन आएगा? AA और BB is going to be less than the interaction between the inter, that is AV. Okay, that is the second point. Next point is, this process is associated with release of heat. Very important, my dear friends. Okay, there it was absorption of heat. यहाँ पर it was release of heat. Now generally exceptional cases are there, but release of heat is associated with contraction. It is associated with compression. और जब भी compression होता है दोस्तों, तो वॉल्यूम में कमी आती है, and that's why we say the volume decreases. वहाँ पर मैंने आपको बोला था absorption है, तो generally expansion होता है, expansion से वॉल्यूम बढ़ता है. यहाँ पर रिलीज हो रहा है, so obviously the volume decreases. Okay? और जब कम होता है, रिलीज हुआ तो दे दिया, कोई भी चीज अगर दे देते हैं तो कम हो जाता है. Okay? तो कम होना मतलब वो नेगेटिव होता है. So therefore we say delta H is negative and delta V is negative. The change in enthalpy is negative, the change in volume is negative. Delta H is negative, that means we generally say that the process is exothermic. Alright? Next point is the vapor pressure curve. Okay, आपको पता चल गया होगा वेपर प्रेशर कर्व पॉजिटिव डिविएशन का कैसा था. सेम वे ओवर हियर. ओके, यहाँ पर आप देख सकते हो ये जो डॉटेड लाइंस है, दोज आर द वैल्यूज व्हिच आर ऑब्टेन्ड बाय राउल्ट्स लॉ. वंस अगेन स्पेलिंग का ध्यान दीजिएगा प्लीज. इट इज RAOULTS. नाउ ये जो कर्व मुझे मिला है दैट इज एक्सपेरिमेंटल वंस, और आप देख सकते हो इन ऑल दीज केसेस द एक्सपेरिमेंटल वन इज गोइंग टू बी लेस एज कंपेयर टू दैट ऑफ द theoretical one, and because it is less, वो नीचे की तरफ जा रहा है, आप देख सकते हो. ओके, वहाँ पर वो ऊपर की तरफ जा रहा था, यहाँ पर वो नीचे की तरफ है. ओके, you can see this pointers, and therefore we say it is a negative deviation. Okay, next is we proceed towards the factors which I have already discussed. Okay, यहाँ पर भी we are going to consider the same factors. पहला, the extent to which polarity takes place. That depends upon the electronegative difference between the combining species. Next point is the intermolecular and the intramolecular force of attraction within the molecule and between different molecules. कितने हद तक attraction होता है. Next one is कितने हद तक association होता है amongst the components of the solution. And of course, if I have a hydrocarbon, then what exactly is the chain length, the extent of chain length. Okay, so these are the factors which are common between the positive deviation as well as negative deviation. All right, and the last point is of course the examples. So पहला example है acetone chloroform. Next we have is hydrochloric acid and water. There are still more, but then we restrict to only a couple of examples. All right, so this is, my dear friends, about the discussion with respect to the deviations with respect to the Raoult's law, the positive as well as the negative deviation. As I said, if you have understood the positive deviation, negative deviation is very easy. It's exactly the opposite of that. So I hope you have understood both the deviations very well and you have enjoyed this particular session. And until we meet next time, Okay, do take care of yourself. Thank you for joining me right now. Take care. Bye bye.